a vertex and then some other stuff. Okay, so you start with the vertex. Then you identify the axis of symmetry, which I abbreviate AOS for obvious reasons. The direction of opening is either going to be up or down based on A, if it's positive, or negative. And then at the end we'll state the domain and range.
Did you need one? What kind do you want?
You don't need a ruler.
Bendy?
Quadratics are curvy.
Yeah. I like having my lines of my graph nice and straight, that's why.
No, but these aren't going to be straight.
No, like the...
She means the axes, yeah.
There's the anxiety when it's not.
Okay, the vertex in quadratic, in quadratic, similar to in absolute values, the vertex is HK. Okay, so anything subtracted from X and then added on at the end. Those are your H and your K. In this case, there is nothing subtracted from X, so the X coordinate is 0. And there is nothing added on at the end, so the Y coordinate is also 0. So there are no vertical or horizontal translations in this particular parabola.
So do you just know that that's the formula and you just kind of plug it
Yeah,
in?
you got to know this guy.
Oh, that's a...
It looks just like the absolute value one. No, this is the general form or general vertex form for a parabola. Then we have standard form. We're going to do that too.
Okay.
Alright, so graph that point. So it's right here at the origin. Okay, in this chapter, in chapter 4, we're only going to be doing vertical parabolas. Later on, I think it's chapter 10, we do horizontal parabolas as well. So our axes of symmetry are vertical lines. They go through the vertex. So vertical lines that go through the vertex. In our situation, the only vertical line I can draw through the vertex is this one right here. Okay, that would be my axis of symmetry. That would go through the x value of 0. Okay, so my axis of symmetry is the line x equals 0.
So axis of symmetry is just
To get more points, you can make a table of values. Table of values. Every point you plug in on the right, wherever that point may be, is going to be reflected across the axis of symmetry. So typically we graph 5 total points for a parabola, but you only need to plug in 2 more because they'll be reflected on the other side. Okay, so I'm going to pick 1 and 2. If my vertex is at 0, 0, I want to pick x values close to the vertex. If I pick 7, it's going to be way too high because parabolas increase really quickly because of the squared part. So you don't want to pick numbers that are far from your vertex. Choose numbers close to vertex. Okay, so if you put in 1, so this one's easy. All you do is square it. What's 1 squared? 1. So you have a point at 1, 1. Because the axis of symmetry is right here, okay, I would also have a point on the other side, okay, at -1, 1.
Wait, you do 2? Wait, what?
So if I have a point at 1, 1, then I have a point on the other side of the axis of symmetry at -1, 1.
Is it always the x that will change from negative to positive?
And because we're doing vertical parabolas only.
I have a question.
Yeah.
Can you explain where you got the 0, 0 again?
So the 0, 0 comes,
Having to do it.
Well, I didn't in my book.
if you plug in 2, what is 2 squared?
2.
2 squared is 4.
Oh,
So you have a point at
2.
2, and then 1, 2, 3, 4. Now, we would also have a point on the other side, reflected. So it's 2 away from our axis of symmetry. It's going to be 2 away over there. Okay, so in addition to 1, 1, you also have -1, 1. In addition to 2, 4, you have -2, 4. And that's 5 points. We can graph our parabola. The direction of opening, okay, is up.
I love doing that. It's so fun.
What's
Drawing
parabolas?
Well, like connecting it.
The reason our direction of opening is up is because A, which was this number right here, was positive. You'd see a negative sign in front of your x if it was negative. Okay, so because this whole thing is positive, That's why it opens up. If it was negative, it would start to go down.
So A isn't like.
So parabolas do not have, they can't just be whatever they want. Okay, like lines can be all real numbers for domain and range, but parabolas have some restrictions. Okay, domain is your set of x values. So is there any x number or number for x that we can't plug in to this guy? Is there anything restricting our domain?
2 and negative 2.
I can't plug in 2. I plugged in 2. I got 4.
Oh, sorry, 3.
3? I could plug in 3. I'd get 9. It'd just be off the graph.
You
They
can't
all
plug
real
in
numbers.
I could plug in 0. I got 0.
No
Negative
numbers.
Y's?
It's no number. It's no solution.
All real numbers.
What
All
was the
real
Negative
question?
Y's?
What was the question?
I asked, is there anything we can't plug in
No.
here?
Oh,
We can
I
plug in
can plug
everything.
What are things we can't do in math? There's like 2 main things that you guys kind of know.
You can't change
You
numbers.
can't divide by 0.
You can't divide by 0. Are we dividing by 0 if we plug in a 0? No. So it's not that. What else can't we do?
Make it negative.
Things can be negative.
You can't not do something to one side.
Nah, yeah. No, I mean like other like basic things though. Square roots.
Oh, you can't have a negative and square root.
You can't square root a negative number. Is there a square root anywhere here? No, so we don't have to worry about that either. So those are the 2 things you're worried about, dividing by 0 and square rooting negatives. We're not worried about that here, okay? So that means I can plug anything into this x and it won't be a problem because I won't be dividing by 0 or square rooting a negative. So your domain is all real numbers.
I knew it. I so called that.
Now we're going to practice interval notation.
No solution.
No, he said no solution.
He said no
Oh.
solution.
I'll take it.
We are practicing interval notation in this chapter. So you're going to write negative infinity to positive infinity.
I don't like drawing an infinity sign because mine looks ugly.
Just go sideways for a second.
Nope.
Draw an 8.
I'm just showing you both ways so that you know what I'm talking about.
Like I said.
You are choosing this one,
It's just a dead 8.
interval notation.
Or sleep.
Does anyone have lead?
No.
You actually?
Yeah.
0.7.
The range is what the y's are doing in reaction to the x's. So, in our parabolas, you're going to try to look at the y coordinate of your vertex. That is going to give you either the smallest or the biggest number that y can be, because your parabola is either going to open up or down. Okay, the y coordinate of your vertex is either going to be the minimum or the maximum of your function. Okay, so what is the y coordinate of our parabola?
0.
0. Do you see how 0 is the minimum value of our function?
Is it like 0, comma, like a 0 with like a parentheses or something, right?
0, comma.
Infinity.
Alright, now, what do I put here?
A bracket.
bracket.
No,
Or is it
no,
parentheses?
Oh, I don't know.
Parentheses.
Is 0 on the graph?
Yes.
Yes.
Then it's a bracket.
What?
If you can see the value on the graph, it's a bracket. Can we see infinity?
Sometimes.
I don't know.
No. You cannot include infinity, but you can include 0 because 0 is on the graph.
Oh, I thought the bracket was when you couldn't include it.
They just
One, we have some more stuff involved, so your vertex is not going to be at 0, 0.
Darn it.
Okay, we need to identify the vertex, the axis of symmetry, and the direction of opening. Let's just say, hold on. I'm not going to abbreviate that. We're going to do open. Okay, if you look, what is being subtracted from x?
Negative 1.
-1. That means that this is moving to the right 1. So your vertex is at +1. Or you have, I don't know. So you have a horizontal translation of right 1, okay? Or your x coordinate of your vertex is at +1. This 3 is a vertical translation. So your parabola is translated up 3. Or your vertex y coordinate is at +3.
Wait, so
Isn't it kind of the same as
yeah, it's the
absolute
same
value?
as absolute value.
Oh, you're so smart. Yeah, it is. It's exactly the same.
Thank God.
The inside of the absolute value just switches.
Yeah, to like parentheses in
Oh,
this
maybe my
case.
graph's not gonna be big enough for this.
No, mine neither.
Is it going up? Can you just tell me that now so that I can?
So if you want to know if it's going up, you're going to look in front of the x or the in front of the x squared. Is it positive or negative? Positive, so it's opening up. And the axis of symmetry has to go through the vertex vertically. Okay, so what line is that? One. What else?
What line is that?
What line is this?
A dotted?
What is the equation of this line?
Oh, I was so confused. X equals 1.
There you go. X equals
What
1.
line is that?
I told it. What kind of line is that?
So confused.
So this one's a little bit more involved. So when you make your table, you might want to make like a step in between to do your math. Up to you. You don't have to do this. You don't want to pick just any values for x. You want to pick values close to the vertex. So if our vertex is at 1, we might want to pick 2 or 3.
My pencil's being annoying.
So plug in 2.
On our quiz or test, am I allowed to like draw that yellow line?
Yeah, you're supposed to.
Oh.
Is that like a rule?
But it's got to be dotted.
Oh, really?
It has to
Yeah,
be dotted?
Because if it's not dotted, then like it's like an extra line
Wait,
in
you
there,
have
and
to
then you
have
have
the
like
line?
an
Yeah,
intersect.
it's an axis of symmetry. You need it.
And then you could have like an intersect. 'cause
Wait,
if you
this-
have the
the
It's
first
usually
one's
it's
4,
usually
right?
asked for.
Really?
Yeah.
Okay, the first one's 4.
First one's 4 because 2 minus 1 is 1. Squared is 1. Plus 3
Next
is.
one is 7.
Make sure you're doing PEMDAS. Everyone messes these up because they don't know their PEMDAS rules.
2
Just-
squared 4 plus 3 is 7. It's 4 7. Oh my god, I really don't have enough room on this stupid graph.
I don't either.
I'm so mad.
7.
All right, so 7. All right, so that means we have a point at 2,
Gosh darn it.
4, and you're going to reflect that point on the other side. So the one on the other side is at 0, 4.
Who just screwed?
I don't know. Yeah, I think I can barely fit 3 7. So 3, this
Okay.
is 7.
I have a question.
Yeah.
How do we know where our the second point will be at? Is it always just like
It's
the exact
equidistant on
opposite?
the other side.
It's like a negative 4.
It's
negative-
reflected across the line.
It's
So
literally
2
like
away
negative
from
2,
that
4,
line.
negative 2, negative 4.
No, it's 0 4 though.
Right, because it's 1 away from the axis of symmetry, which is at 1.
I really am.
Wait,
Equidistant
Use a
from
mirror
the
for
axis
the-
of symmetry.
5, 6. Yes.
So, domain and range.
I don't wanna.
What's the domain?
All real numbers.
Is it ever going to be not all real numbers?
Yes.
If
When
it's
it's
a
going
parabola,
horizontal.
if it's parabola,
When it's a parabola.
no, it's always gonna be an all real numbers.
Can you do
Parabolas-
to the side?
This is the
Parabolas are quadratic. So, is there any number you will ever not be able to square?
Nope, no.
No, we can square positives, we can square negatives, we can square
Decimals.
0, we can square decimals, we can square fractions, we can square all kinds of numbers.
Square pi.
So your domain is always going to be all real numbers, but your range is always not going to be all real numbers. It's going to be something else.
It's bracket 3,
Can you
comma,
actually square pi?
infinity, parentheses.
Correct.
So
Yes.
if I put all real numbers down, then I'm good, right?
For domain.
You're so
So I get like
confident.
some.
No, you need to do interval
Bracket
notation. We're
3,
practicing
comma,
interval
infinity.
notation.
Bracket 3, comma,
Can you
infinity.
square pi?
All right, so we are going to solve some word problems.
What?
It says
Come on.
this function is a model for height in feet, okay, of a ball thrown after t seconds. So as time increases, the height is going to react. I don't know, I haven't graphed it, so I don't actually know if it's going to increase or decrease, but I do know because I'm smart and I know there's a negative sign there. So the ball, when you throw it, typically goes up and then it comes down, unless you just drop it. So we'll see. The first thing we need to do, we're going to treat this t like it's an x, okay? So the first thing we need to do is we need to know our vertex.
Wouldn't that be just be 2, 4?
Yes. So vertex is 2, 4.
I drew an equal sign instead of a subtraction sign, and I don't know why.
So the axis of symmetry would be negative 2, 4, so just be x equal negative 2.
X equals just 2, because remember this is positive 2.
Oh, okay.
So 2, 4, and then axis of symmetry goes through that.
Oh, maybe I should draw my graph.
That would be helpful.
And
Maybe I
then
should.
would it be down?
This is going to open down because of the negative.
Oh wait, but he's like in. Are they gonna be big numbers? Because I just want to know.
But then where's the surprise? Notice this is in function notation. So h of t is like y. That's the height after a certain period of time. So you're going to plug in values for time and you're going to get values for h, or the height. Because the vertex is at 2, 4, we want to plug in values close to that. So like 3 or 4. So if I plug in 3, I get 3 minus 2, which is 1. 1 squared is 1, times negative 1 is negative 1, plus 4 is 3. Sorry.
I can't math. I'm still drawing my lines.
Why haven't I not put arrows at the end of this parabola?
You don't put arrows?
Why didn't I put arrows?
Because it ends in
Because
X.
is on a line.
Because why
Well,
bother, right?
What does y represent in this question, or h of t?
The end of the. Like, it's like
What does it say it represents?
Oh, when the ball hits the floor.
Or when
Okay.
it's high.
So what would a negative 1 y value be?
If they dropped it. If the ball
No.
never stopped dropping.
What is y? What variable?
Y is H, so when
So what is h representing?
Height.
Okay, so what
Oh,
would
they
negative 1 represent?
When
Negative
below
1
the
second.
floor.
Below the floor. Does that make sense?
Below ocean
Yeah,
level.
because think about it like this.
No.
Think about it like this.
No.
If
You
shut
can't
down-
go below the floor, okay? So your height is restricted by the floor, okay? And therefore your t values are also restricted. The biggest t value is 4 seconds and the smallest is 0, because that is what would if
Would
you
that
were
be your
to
answer?
if you were to decrease t or increase t past those values, you would start being underneath the ground, and that doesn't make sense unless you're like
Ghosts.
digging.
I dug a hole and then
Or it's
Digging.
water. No, the answer it says when will the ball hit the floor? So what's the answer?
0.
After 4 seconds.
Yeah.
Oh.
Or
I'm
at.
really just
It's
guessing.
more like at 4 seconds, but at after. I guess it's all relative to how you like to phrase your words.
I like using nice long words like after, because it's really specific. to
And
me
you
and
use the
makes
maximum value for that,
Why
right?
after?
Like how would you?
No. This is when t or time is 4 seconds, okay, and my height is 0. So the floor is where the height is 0. So that's how I know it's hitting the floor.
Long throw.